Good afternoon, everybody. Today we are discussing the next topic of the nuclear chemistry, that is the nuclear reactor. This is the image of a nuclear reactor. The nuclear reactor is an arrangement in which the release of the nuclear energy through a self-propagating fission chain reaction at a constant rate. And you know that there is a fissionable material is present in the nuclear reactor, and the presence of the fissionable material equal to or greater than that of a critical mass. Critical mass means the minimum amount of the mass of the nuclear fissionable material which is present in the reactor to continue the nuclear chain reaction of fission reaction in a controlled manner. So, you know that after every nuclear fission reaction, the nuclear material will emit one or two neutron. So we have to regulate the speed of this neutron. In order to reduce the speed of the neutron, we are using moderator, and we are usually using moderator as graphite or heavy water to reduce the or to control the speed of a neutron. Next, by inserting the control rods of neutron absorber such as cadmium or boron. So the purpose of the control rod is to regulate the amount of the or number of the neutron inside the reactor. Then by minimizing the neutron loss by controlling the size of fuel which is equal to or above the critical size and having the minimum surface area as possible. These are the conditions of a reactor, nuclear reactor. So first condition, the material which is present in the nuclear reactor must have the critical mass. The second one, we have to reduce or control the speed of a neutron by using moderator. The third one, we have to regulate the number of the neutron inside the reactor by using control rod. And the last one, we have to minimize the neutron loss by controlling the size of the fissionable material and surface area. We have to reduce the surface area minimum. So that's why we have to make the fissionable material in the form of a sphere. Now we are moving into the first nuclear reactor. The first nuclear reactor is shown in the figure photograph. So this is the first reactor, and its name is Chicago Chain Reacting Pile, and it was started in 1942. The fissionable material which is used in the Chicago Chain Reacting Pile is the natural uranium, which containing 0.72% of uranium-235 and bulk being mostly of uranium-238. And in Chicago chain reacting pile, they are used graphite as a moderator and cadmium as the control strip. Now, this is the simple diagram of a nuclear reactor, modern nuclear reactor. And there are lot of features for a nuclear reactor. There are 5 features for a nuclear reactor. First one is a fuel. Second one is moderator. Third one is a control rod. And the fourth one is a reactant coolant. And fifth one is a shield. Now we are moving into the individual features in detail. So first one is the fuel. Nuclear fuel. We know that the nuclear reactor must contain a fissionable material. Since the nuclear reactor is following nuclear chain reaction, fission chain reaction. So that's why our fissionable material may be uranium-235 or uranium-233 or plutonium-239. If you use the natural uranium as a fissionable material, natural uranium contain 0.72% of the uranium-235 And there are one more fissionable material is also available, that is the enriched uranium. Enriched uranium contain higher amount of the uranium 235. And the part of the reactor which containing the nuclear fissionable material is known as nuclear reactor core. Next is the moderator. We are already discussed what we mean by moderator. Moderator mean which can slow down the secondary neutron which is produced during the nuclear fission reaction through the collision. So naturally we are using graphite, heavy water or beryllium oxide or water as the moderator, which will slow down the neutron which is emitted in the every nuclear fission reaction. So next feature is the control material. Control material means certain non-fissionable material are used to absorb the thermal neutron in order to reduce the number of the neutron to continue the sustainable chain reaction. Example, cadmium and boron. And in order to shut down the nuclear reactor, we have to insert the control rod in a considerable depth. And in order to start up the reactor, we have to withdraw this control material in a particular depth. So these are the controlling material which is used in a nuclear reactor. The name indicates its role. Control material means which is control the nuclear chain reaction which is occur in the nuclear reactor. The fourth one is reactor coolant. Coolant means the reactor coolant is used to remove the heat generated in a nuclear fission chain reaction. Mostly we are using the coolant is the coolant is pumped through a reaction core. And so see here, the orange one is the orange colored bar is the fissionable material. In between we can see an ash colored strips, and these are the graphite moderator. And above the figure we can see the control rod that is in black color, and between this we can see a blue colored pipe that is a steam generator which is used as a coolant. So reactant coolant is used to remove the heat generated in the fission chain reaction. Mostly you are using the coolant as a water, and coolant is pumped through the reactor core and it is then passed through an external heat exchanger for the production of the steam. And this steam is used for the preparation of the electricity. And again this water is returned into the reactor in a closed cycle. We are using ordinary water or heavy water or liquid sodium or organic polyphenol as a liquid coolant, and we can also use the gas coolant like air or carbon dioxide. So next feature is the reactor shield. Usually the modern reactor have two shield. The role of the shield is which cover the whole reactor and which protect us from the hazardous gamma rays. And there are two shields for the modern reactor. First shield is a thermal shield which is made up of few inches of the iron or steel close to the core and which can be readily cooled and reduces the heat damages. The second shield is the biological shield, capable of absorbing both gamma and neutrons and which consisting of a layer of the concrete several feet in thickness which is surrounding the core. So I will give you the image. This is the reactor and the central one is the fissionable material fuel element which is shown in the orange color strips. and in between we can see a ash color strip which is the graphite moderator. We can see the control rod on top, black colored one, and the reactor is surrounded by a water coolant. We can see a blue colored coolant, and this uh, the water which is present in this blue colored coolant will used for removing the heat generated in the every nuclear fission reaction. And this heat, due to this heat energy, the water inside this coolant converted into steam, and this steam is used for the heat generation, sorry, the electricity generation. After that, again this water is recycled to the reactor, and every reactor is closed in a concrete sheet in order to protect us from the gamma ray. I hope you understand the concept. Thank you.